In these next couple of examples, we're going to be exploring how we can use function rules to complete tables of values and then use that information to graph the function. So for the first example, we're going to complete the table for this function, f of x equals 2x plus 5. And then we're going to graph the function with the data that we gather in this table that we have set up. So what you'll notice down below, I've set up our table in 3 columns. The first column are our different input values that we're going to test out in our function rule. Because one thing we have to remember is that when we're graphing functions, there are multiple inputs that we can plug in order to look at how the output values relate to each other. So first column are going to be some test values that we're going to be plugging in. And just as a general rule for evaluating functions or making tables, I like to use values that are what I would call consecutive integers. Consecutive integers are just simply positive and negative numbers that are in order, in sequence with each other and grouped together within a certain interval. Now you're probably wondering, well, why did you use -2 through +2? Typically, whenever you're wanting to graph a function rule, the behavior of your function rule will sometimes cross over into multiple quadrants in your coordinate plane off to the side over here. So I'm going to be using just the sample set of -2 through +2 just to give me a decent interval of input values to test out and plug in. So what I've done for the first example here, I've showed you the work of what it looks like when we evaluate the function rule at f of -2. And so when you work it out, you get an output of 1 for that. So the ordered pair, the way how we get our ordered pairs from this information, again, an ordered pair is just the relationship of the x-coordinate and the output variable, or the y-coordinate. And remember, f of x is the same thing as y, so our first ordered pair would be at -2, 1. So we can go down the list and then we can work out the rest of these values for the next inputs down below. So I'm just setting up all my work for each one of these, and we're going to work these out. So 2 times -1 is -2. -2 plus 5 is 3. And then 2 times 0 is 0. 0 plus 5 is 5. The next one, 2 times 1 is 2. 2 plus 5 is 7. And then f of 2 is 2 times 2, which is 4. 4 plus 5 is 9. So you'll probably notice that there is a pattern to these resulting outputs that I get. Now let's look at what the ordered pairs would look like. So the next one down would be the ordered pair, -1, 3. The next one would be at 0, 5. The next one would be at 1, 7. And then the last one would be at 2, 9. Now, could you keep going down the list and plug in more positive and negative numbers? Absolutely. But remember, when we're graphing the function, we just need a small sample of input values to test out in order to get an accurate picture or display of what we're going to get once we plot these points out. And one thing to keep in mind is that function rules are what we would call continuous. In this situation, this gives us continuous data. Now you're probably wondering, well, what do you mean by that? Well, continuous data means that I can even plug in numbers in between the integer values, like fractions and decimals, and I can still get values that would be in between these numbers here. So let's plot these points out. So the first one is at -2, +1. So remember, you always start at the origin, and then remember, x is always in the left and right direction, y is in the up and down direction. So the next point is at -1, +3. So left 1, up 3. The next one would be at 0, 5. So for our x-coordinate, we don't move left or right, but we just move up 5 units. Then at 1, 7. So right 1, up 7. And remember, make sure you're being careful with your steps here. And then 2, 9. So right 2, up 9. And remember, it's always with respect to the origin every time we plot these points out. So you'll probably notice here that we have a certain behavior to the way on how these points are behaving in relationship to each other. So we can actually represent this graph using a continuous line. So imagine we were to extend out this line forever in both directions. And so by graphing this, we're looking at all the possible output solutions as we look at all of the possible input values that would work for this function rule. So I hope this first example makes sense on the steps that you would take for plugging in your input values and working it out. So let's try this next example out down below. We're going to complete the table for g of x equals x minus 7. So remember that your function name variable doesn't always have to be f. It can be any other letter of the alphabet as well. Just remember that this is the same thing as this is our output variable right here, or our y coordinate. So if you want to, pause the video right here and you can try this out on your own. And then when you're done, hit play and then compare your work to what I'm going to have demonstrated out for you down below. So let's try these out. So for the first one, g of -2 is equal to -2 minus 7, which gives us an output of -9. So the first coordinate is at -2, -9. The next one, g of -1, will be -1 minus 7. -1 minus 7 is -8. So -1, -8 is our next order pair. Then we have g of 0, which is 0 minus 7, which is -7. So 0, -7 is our next order pair. Then g of 1 is 1 minus 7, which is -6. So our next order pair is at 1, -6. And then g of 2 is 2 minus 7, or -5. So our last order pair would be at 2, -5. So now let's plot these points out. So the first one, so we go left 2, down 9. So right there. Then the next one is at -1, -8. So right there. Then 0, -7. 1, -6. Then 2, -5. And so again, we got this relationship between all of our input and output values. So the way how we would graph our function, we would just draw a continuous line through all of these data points. So you're probably wondering, well, how do we describe the relationship between the x and the y values of both of these function rules? Well, they're lines, so these would actually be classified as linear functions. So a linear function, so here's a new term for you guys. A linear function is just a function rule that represents a line. I hope you found this information useful. Let me know if you have any questions about the topic that we looked at today, and I'll be glad to address any questions or concerns if you have them. Hope you have a great day, and we will continue on with the rest of the lesson material throughout the rest of this week. Goodbye.